Welcome to this video. My name is Mark Scythian. The date today is July 28, 2024. This video is the revised version of impact force. The previous impact force video lectures had a major error. The change in momentum is not a function of the kinetic energy. It's actually a function of the dynamic force. So the simplicity of calculating the impact force is observing that the energy is conserved and the force incurred is equal and opposite upon impact. So we can just calculate the dynamic force of the vehicle in motion. In this case, the impact force is equal to the dynamic force, or the 5,000 pound vehicle weight times its final velocity divided into the gravitational acceleration constant in the US system of measure, or 32.2 feet per second squared. So that 13,665 pounds force as a positive value will then incur equal and opposite as a negative value upon impact. So that is the base value, but what is interesting is the impulse time here is the change in momentum, the delta P, divided into the dynamic force. So if we just convert all of these values into the metric system to get the kilogram meters per second for momentum, we have then the initial momentum of the pounds weight divided into 2.2, so 2272.7 kilograms times 88 feet per second converted from 60 miles per hour, then divided into 3.28 feet to a meter, so 26.8 meters per second is the velocity. So we get a initial momentum of 60,908 kilogram meters per second, and then substitute that in the numerator. And so if we just want to accurately factor label unit, cancel out units with consistency, we can rename the Newton's force as what it is, the kilogram meters per second squared. And so then we reduce everything down into increments of time seconds. And because it's equal and opposite for practicality, we can also equate this as the absolute value of the impulse time. So in this case, it's approximately 1 second impact time. And then the impact force is negative 13,665, equal and opposite to the initial dynamic force prior to impact. So this is the revised version, and of course, if we equate this to like projectiles, we would have a much smaller momentum value, like a very high-speed projectile or bullet with a much smaller, lower mass, then divided into a substantial amount of force. And so then the impulse time would be in fractions of a second, but because the vehicle momentum and its initial dynamic force are relatively close to each other, the ratio is going to be approximately, in this case, almost 1 second, or about 1 second. So if this was observed experimentally in slow motion, like high frame per second cameras, you can pretty much measure almost a second of impulse time upon impact. But this same concept can be applied to anything else that's incurring sudden impact, like dropping a hammer on a table or projectiles making impact. So I'll redo those videos and add it to the first revised impact force video. That will be a follow-up video to this one. So thank you for watching this video and have a great day.